Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi, Herman and Corn. So if there's one subject that pretty much nobody likes talking about, it's probably the sewer system. Every time we use the toilet, something goes into action, and really that infrastructure is the ultimate hidden world. I mentioned that in a previous job for an industrial IoT company. One of the products was sold into sewer networks and basically monitoring for stuff like toxic gases. I kind of always wondered what the sewers underneath our city looked like, but I'm also not a very brave or adventurous person. So I've limited myself to watching YouTube videos where you have some crazy urban explorers who literally go down into these things. And I can't imagine that it smells wonderful down there. But I'd love to ask you, Herman and Corn, about this infrastructure that is beneath our cities. I don't know in the case of Israel how modern it is and what period it dates back from in our urban areas, but I was really surprised to see that some of the sewers that still exist in London are literally from Victorian times, like the 19th century. And I guess it just fascinates me that infrastructure that is that old can actually still work reliably. I also can't imagine that anyone's in a particular rush or enthusiastic about the job of swapping out sewer networks. It doesn't sound like the best job either for the people doing it or for anyone else. It's a net loss, but I presume it sometimes has to be done. So Herman and Corn, both in the Israeli context and in the broader global context, what is the state of infrastructure in sewers? Does most of the world and the cities have sewerage systems that are actually really, really old? How do they get maintained? If they need to stay in workable condition, and if it's not feasible or practical to just rip up and replace a sewer system, how often do these things actually need human investigators? And I say human because I mentioned the IoT thing for a reason. We know that there is an awful lot that we can do with IoT in this context, but the major problem with storage systems is the fact that they're buried underground, and we know that concrete is the archenemy of cellular networks. So my question is for municipalities and governments that are trying to bring some smart capabilities into their storage systems to reduce the number of times, because something that I do recall from working in this IoT company is that the actual process of sending a technician into a sewer is not a simple thing. You have to get a permit for. They're incredibly safety conscious. They're highly trained personnel, and to send one down is therefore quite costly. So there's an financial incentive to avoid too many human inspections as well. So Herman and Corn, let's talk about the hidden infrastructure world. Storage systems, both here in Israel and abroad, how do they work? Are they all old and decaying? And to what extent are we able to use technologies like AI and the IoT so that the humans have to make less trips down into this murky underworld?
It is the ultimate out of sight, out of mind situation, right? We go about our lives here in Jerusalem, walking over these ancient, sun-drenched stones, and we almost never think about the labyrinthine network of pipes and tunnels pulsing right beneath our feet. It is a parallel universe, a shadow city that mirrors our own, but we only acknowledge it when the mirror cracks. As soon as something goes wrong, as soon as a drain backs up or a sinkhole opens on a busy street, it is suddenly the only thing anyone can talk about.
It is the literal foundation of civilization. Corn, truly. You can have the fastest internet, the most advanced quantum computing, and the tallest skyscrapers, but if you cannot manage your waste, the city dies within 48 hours. I am Herman Poppleberry, and I have actually been looking forward to this because our housemate Daniel sent us a fascinating prompt about this hidden world. He has some professional background in industrial Internet of Things, so he knows just how difficult it is to get data out of a hole in the ground. It is one of the last great frontiers for the digital revolution.
Yeah, Daniel was mentioning that the very materials we use to keep our city standing, like reinforced concrete, thick soil, and heavy cast iron, are basically the natural enemies of radio waves. It is a massive technical hurdle. But before we get into the high-tech solutions of 2026, let's look at the scale of the problem. Some of these systems are incredibly old. Daniel mentioned London, which is famous for its Victorian sewers. But how deep does that history actually go?
It is incredible, really. If you want to go to the very beginning, you have to look at the Cloaca Maxima in Rome, which dates back to the 6th century before Common Era. Parts of it are still used for drainage today, over 2,500 years later. But the modern sewer, as we understand it, a comprehensive, engineered system for a metropolis, that is a 19th century invention. In London, you are looking at a system largely designed by Joseph Bazalgette in the 1860s. Before that, London was essentially a giant cesspit. People were dumping everything into the Thames, which was also where they got their drinking water. It was a recipe for cholera and death.
And that led to the Great Stink, right? I remember reading about that.
Exactly. The summer of 1858 was unusually hot. The Thames was so full of untreated human waste and industrial runoff that the smell became unbearable. It was not just a nuisance, it was a political crisis. The smell was so bad they had to drape curtains soaked in chloride of lime over the windows of Parliament just to be able to work. They actually considered moving the entire government out of London. That is what finally gave Bazalgette the funding and the authority he needed. He designed a system of 82 miles of main intercepting sewers and 1,100 miles of street sewers. And the crazy part? We are still using a lot of that exact same brickwork today, over 160 years later.
That is mind-blowing. I mean, think about the population growth since 1860. How does a brick tunnel designed for a city of perhaps 2 or 3 million people handle a modern metropolis of 9 million?
It barely does. That is the core of the issue. Bazalgette was a visionary. He actually doubled the diameter of the pipes he thought he needed, which is why they lasted this long. But they are at a breaking point. When you have heavy rain, the system gets overwhelmed. These are what we call combined sewer overflows. In a combined system, the rainwater and the sewage go into the same pipe. When it rains too hard, the treatment plants cannot handle the volume, so the excess, a mix of rainwater and raw sewage, is discharged directly into the river. It is a global problem. New York City, Paris, Tokyo, they are all wrestling with this aging, 19th century infrastructure while trying to meet 21st century environmental standards. In the United States alone, there are nearly 800 cities that still rely on these combined systems.
And then you have the maintenance aspect. I have seen those videos Daniel mentioned. The urban explorers and the professional sewer hunters. It looks like a different planet down there, with these massive cathedral-like brick arches. But for the technicians, it is not an adventure. It is high-risk work.
Extremely high risk. You are dealing with confined spaces, which is dangerous enough because of the risk of collapse or flash flooding, but then you add in the gases. Hydrogen sulfide is the big one. It is a byproduct of organic matter breaking down in an anaerobic environment. In low concentrations, it smells like rotten eggs, but at high concentrations, it actually deadens your sense of smell. It paralyzes the olfactory nerve, so you do not even know you are breathing it until you collapse. We call it the knockdown effect. Then there is methane, which is explosive, and carbon monoxide. It is a toxic, flammable, dark, and damp environment. Sending a human down there is always a last resort, or at least it should be in 2026.
Let's bring it closer to home. We are sitting here in Jerusalem. What is the state of the infrastructure beneath us? Israel is a relatively young country, but this is one of the oldest continuously inhabited cities on Earth. That has to create some unique challenges for a plumber.
It is a fascinating layer cake of history. In some parts of the old city, you are literally walking over drainage channels that are 2,000 years old, dating back to the Second Temple period. When they do modern sewer work here, they often run into archaeological sites. You cannot just dig a trench in Jerusalem without a team of archaeologists standing by. I remember a project near the city of David where they were trying to repair a 20th century pipe and ended up uncovering a massive Herodian-era drainage tunnel that was so well preserved you could still walk through it. But in terms of modern infrastructure, Israel is actually a world leader in one specific area, which is wastewater reclamation.
Right, the Shafdan plant. We have talked about that briefly before, but the scale of it is worth repeating because it is truly a global outlier.
Exactly. The Shafdan facility, which handles the wastewater for the entire Tel Aviv metropolitan area, is one of the most advanced in the world. Israel recycles nearly 90% of its wastewater for agricultural use. For context, the next closest country is Spain, which is somewhere around 25 or 30%. Most countries, including the United States, are in the single digits. We treat the water to such a high standard that it can be used to irrigate crops in the Negev desert. So, while the pipes in the ground might be aging in some of our older cities like Haifa or Jerusalem, the actual processing of that waste is incredibly high-tech. However, the collection network, the thousands of kilometers of pipes leading to the plant, is still vulnerable.
But even with great processing, you still have the problem of the pipes themselves. If a main line breaks under a busy street in West Jerusalem, you have a catastrophe. You have sinkholes, you have contamination, and you have massive traffic gridlock. How do we move away from this reactive model where we only fix things when they explode, towards something more proactive?
This is where Daniel's interest in the Internet of Things and artificial intelligence comes in. The goal is what engineers call the smart sewer. Traditionally, if you wanted to inspect a pipe, you would do a CCTV inspection. You send a little tethered camera on wheels down the pipe, and a human sits in a van watching a monitor for hours, looking for cracks, root intrusions, or structural deformities. It is slow, it is expensive, and humans get tired. They miss things. They might see a spider web and think it is a crack, or see a crack and think it is just a shadow.
So, I assume the first step is automating that visual inspection?
Precisely. We are now seeing the deployment of autonomous or semi-autonomous robots. Companies like Sewer AI and others are using computer vision models to identify anomalies. These AI models have been trained on millions of images of pipe defects. They do not get bored. They can flag a hairline crack or a slight misalignment in a joint with way more consistency than a person. And it is not just cameras anymore. We are seeing robots equipped with LiDAR, which is light detection and ranging, to create three-dimensional maps of the pipe interior. This allows engineers to measure the exact thickness of the pipe wall or the precise volume of debris sitting at the bottom.
But that still feels like a snapshot in time. You put the robot in, it does the scan, you pull it out. What about real-time monitoring? That is what Daniel was getting at with the Internet of Things. If you have sensors down there permanently, you can see the pulse of the city every minute of every day.
That is the dream, but as Daniel pointed out, the physics are brutal. You are inside a tube made of concrete and rebar, buried under several meters of earth and asphalt. It is a perfect Faraday cage. Radio waves do not like to travel through that. If you put a standard Wi-Fi or cellular sensor in a manhole, the signal often cannot reach the surface. It is like trying to make a phone call from inside a lead box.
So how are they solving that? Are they running wires to every sensor? Because that sounds like an infrastructure nightmare in itself.
No, wiring is too expensive and prone to damage. The breakthrough is coming from low-power wide-area networks, like LoRaWAN or narrowband Internet of Things. These technologies use lower frequencies that have much better penetration through obstacles. They also send very small amounts of data, just a few bytes at a time. You do not need to stream high-definition video from a permanent sensor. You just need to know the water level, the temperature, and the concentration of hydrogen sulfide.
So you have these little nodes scattered throughout the network, chirping out data once every 10 minutes.
Exactly. And to get the signal out, they often use the manhole cover itself as a sort of antenna, or they install a small, ruggedized antenna that sits just below the street surface in a protective housing. Some companies are even experimenting with acoustic monitoring. Instead of radio, they use sound. They send a pulse of sound through the air inside the pipe and listen to the echo. The way the sound bounces back can tell you if there is a blockage or a buildup of grease without ever needing to see it. It is like sonar for sewers.
Oh man, the blockages. We have to talk about the fatbergs. That is the word that always makes people cringe, but it is such a vivid description of the problem.
It is a disgusting reality of modern urban life. For those who do not know, a fatberg is a massive, solid mass in a sewer system formed by the combination of non-biodegradable solids, like wet wipes, and congealed fat, oil, and grease, which engineers call FOG. People pour cooking oil down the drain, and it hits the cold water in the sewer and solidifies. It undergoes a process called saponification, basically turning into a giant, hard block of soap. Then it catches all the wet wipes that people mistakenly flush. In London, they found one in 2017 that was 250 meters long and weighed 130 metric tons.
That is the size of 11 double-decker buses. How do you even get rid of that? You can't just flush it away.
It is a nightmare. Humans have to go down there with high-pressure hose jets and literally pickaxes to break it apart. It is dangerous, backbreaking, and frankly, revolting work. But this is where predictive AI is starting to help. By monitoring flow rates and using those acoustic sensors I mentioned, utilities can identify where a fatberg is starting to form before it becomes a 100-ton monster. If the flow starts to slow down in a specific branch, the AI flags it. They can send in a smaller, specialized jetting robot to clear the grease while it is still soft. It is much cheaper to clear a 10-pound grease ball than a 100-ton fatberg.
It is interesting how the technology has to adapt to the specific biology of the sewer. It is not just about mechanics, it is about chemistry. I read something about using microbes or specific chemical sensors to detect the health of the concrete itself. Because the hydrogen sulfide isn't just toxic to humans, right? It actually eats the pipes.
You are spot on. It is called microbiologically induced corrosion, or MIC. There are certain bacteria, like thiobacillus, that thrive in sewers. They take that hydrogen sulfide gas and turn it into sulfuric acid. That acid then eats away at the concrete walls of the pipe until it becomes structurally unsound. It turns the concrete into a soft, mushy substance called ettringite. This is a huge reason for those sudden road collapses you see in the news. By the time the surface looks bad, the pipe underneath might have been hollowed out for years.
So, if we have sensors that can detect the chemical composition of the air and the pH of the water in real time, we could potentially map out the corrosion risk across an entire city. We could say, okay, this section of North Jerusalem is corroding faster than expected. Let's prioritize it for a liner before the road falls in.
And the liners are another cool bit of tech. You do not always have to dig up the street to replace a pipe anymore. They have this thing called cured-in-place pipe, or CIPP. They basically pull a flexible resin-saturated tube through the old pipe. Then they inflate it and use steam or ultraviolet light to harden the resin. It creates a new, jointless plastic pipe inside the old one. It is like giving the sewer a new set of arteries. It can add 50 to 80 years of life to a system without a single shovel hitting the dirt.
That seems like a massive win for the city. No traffic jams, no noise, no massive construction projects. But I imagine the cost of the sensors and the AI analysis is still a hurdle for a lot of municipalities that are already struggling with budgets.
It is, but you have to look at the alternative. The cost of a major sewer collapse in a city center can be millions of dollars in direct repairs, not to mention the economic loss from closed businesses and diverted traffic. The return on investment for smart sewer tech is actually very high. In the United States, for example, the Environmental Protection Agency estimated that it would cost nearly $300 billion over 20 years just to maintain and improve existing wastewater infrastructure. If AI and IoT can make that maintenance even 10% more efficient, you are saving $30 billion. That pays for a lot of sensors.
Let's talk about the data side of this. If we are collecting all this information, what else can we do with it? I have seen studies where they use sewer data for public health, which sounds a bit like science fiction, but is actually happening right now.
That became a massive tool during the pandemic and has only expanded since then. It is called wastewater-based epidemiology. Because people shed fragments of viruses and bacteria in their waste before they even show symptoms, you can actually predict an outbreak in a specific neighborhood about a week before the clinical tests start showing it. During 2024 and 2025, many cities used this to track new strains of influenza and even the resurgence of polio in certain areas. In Israel, we have one of the most robust wastewater monitoring networks in the world. It allows health officials to target vaccination campaigns to specific blocks rather than locking down an entire city.
That is incredible. It turns the sewer system into a sort of early warning system for the entire city. It is like a diagnostic test for the population.
It really is. And it goes beyond viruses. Researchers are now using it to track the use of opioids and other drugs in real time to help emergency services prepare for spikes in overdoses. They can even track the levels of cortisol, the stress hormone, in a population. Of course, that brings up some interesting privacy questions. If you can tell what a neighborhood is eating, drinking, or what medications they are taking, where do you draw the line? But on a neighborhood level, the data is anonymized enough that it is just a powerful tool for public health officials to allocate resources.
You know, it occurs to me that as we make these systems smarter, we are also making them more vulnerable in a different way. If the sewer system is connected to the internet, even through a low-power network, does that mean it can be hacked? We have seen cyber attacks on power grids and water treatment plants.
That is the big fear with all critical infrastructure. If a malicious actor could gain control of the automated sluice gates or the pumping stations, they could cause massive flooding or environmental damage. Imagine someone remotely opening a gate that releases millions of gallons of sewage into a protected waterway. This is why the security for these industrial Internet of Things devices has to be incredibly robust. You cannot just use default passwords. You need end-to-end encryption and very strict access controls. It is a classic trade-off. We want the efficiency and safety of a connected system, but we have to accept the cyber risk that comes with it.
It feels like we are moving toward a world where the city is treated more like a biological organism. It has a nervous system of sensors, a digestive system of pipes, and an immune system of AI that identifies and fixes problems.
That is a great analogy. And like any organism, it needs regular checkups. I think the goal for the next decade is to get to a point where no human ever has to enter a sewer for a routine inspection. We should save those risks for only the most complex, unpredictable repairs that a robot simply cannot handle. We are seeing the rise of digital twins, virtual models of the entire sewer network that update in real time based on sensor data. An engineer can put on a virtual reality headset and walk through a digital version of the Jerusalem sewer system to see where the problems are without ever getting their boots dirty.
So, for the people listening who might be working in urban planning or civil engineering, what is the first step? Is it just a matter of buying some robots?
It starts with the data. You cannot manage what you do not measure. Most cities have maps of their sewers, but many of those maps are old, paper-based, and inaccurate. The first step is a comprehensive digital twin. You need a highly accurate, three-dimensional model of the entire network. Once you have that, you can start layering on the real-time data from sensors. You start with the high-risk areas, the oldest pipes, the ones under the most critical roads, or the ones near sensitive environmental areas.
And for the rest of us, the regular citizens of Jerusalem or London or anywhere else, what can we do to help this aging infrastructure survive?
The takeaway is simple, but it makes a huge difference. Stop flushing things that aren't meant to be flushed. No wet wipes, even if the packaging says they are flushable. They are not. They do not break down fast enough and they become the rebar for fatbergs. And never ever pour grease down the sink. Put it in a jar, let it solidify, and throw it in the trash. We are all part of this system, and the more we treat it with respect, the less likely it is to bite us back.
It is funny. We started talking about this hidden, gross world, but it really is a marvel of engineering. I have a newfound respect for those Victorian bricklayers in London. They built something with hand tools and horse-drawn carts that outlasted empires and survived world wars.
They really did. Basil Geddes was a visionary because he understood that a city is only as healthy as its lowest point. He knew that he was building for a future he would never see. That is the kind of thinking we need today with our digital infrastructure. We need to build systems that will still be functioning in some form 100 years from now, even as the technology above ground changes beyond recognition.
Well, I think we have covered a lot of ground today, from the great stink to the Internet of Sewers. It is a lot to digest, if you will pardon the pun.
Pun accepted. It is a deep topic, Corn. I am glad Daniel sent this one in. It is exactly the kind of thing people overlook until it is too late. It is the silent heartbeat of the city.
Definitely. And, hey, if you are listening and you are finding these deep dives into the hidden parts of our world interesting, we would really appreciate it if you could leave us a review on your podcast app. Whether it is Spotify or Apple Podcasts, those ratings really do help other people find the show and keep us exploring these weird prompts.
They really do. It makes a huge difference for us and helps us grow the community.
So, thanks for listening to my weird prompts. You can always find us on Spotify and at our website, myweirdprompts.com, where we have our full archive of episodes and some extra resources on the topics we cover.
We will be back next week with another prompt. Until then, stay curious.
And watch where you step. Goodbye, everyone.
Goodbye.
It really is fascinating how much we rely on this. I was thinking about the energy aspect too. Some cities are actually starting to recover heat from their sewers, right?
Oh, absolutely. Wastewater is generally warmer than the surrounding ground because of all the hot showers, dishwashers, and industrial processes. You can use heat exchangers in the sewer lines to provide heating for buildings. In some parts of Scandinavia, and even in Vancouver, they are using sewer heat to warm entire neighborhoods. It is another way the sewer is becoming a resource rather than just a waste stream. We are moving toward a circular economy where even our waste provides energy.
See, there is always one more layer. It is a resource, a data source, and a historical archive all in one.
Always. The deeper you dig, the more you find.
Alright, let's wrap it there before we start talking about sewer-based power plants for another 20 minutes.
Sounds good. I need to go check my own pipes now.
Take care, everyone.
Bye.
I think we really hit the word count on that one, Herman. We covered everything from ancient Rome to 2026 AI.
I could talk about Basil Geddet for another hour, honestly. The man was a genius. He used 318 million bricks. Can you imagine the logistics of that in the 1860s?
Maybe in episode 700, we can do a dedicated biography.
Deal.
Okay, shutting down the mics now.
Catch you later.
Wait, did we mention the website?
Yeah, you said myweirdprompts.com.
Right, just making sure. I always worry I forget the call to action.
We are good. The listeners know where to find us.
Okay, for real this time. Goodbye.
Bye.
Actually, before we go, I just remembered that story about the alligators in the New York sewers. That is a total myth, right? I mean, with all our sensors now, we would have seen one by now.
Total myth. It is too cold for them in the winter, and there is nothing for them to eat but rats and trash. Plus, the sheer amount of toxic chemicals and the pH levels would kill them pretty quickly. If there were alligators down there, our AI vision models would have flagged them as a very large, scaly anomaly years ago.
Good to know. My childhood fears are officially debunked by modern data science.
Glad I could help. Now, let's go get some lunch.
Just nothing too greasy. I don't want to contribute to any fatbergs after that conversation.
Fair point. Salad it is. Or maybe just a very lean soup.
See you guys.
Bye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.